Welcome, and thank you for joining us for Improve Your Process, Capacity, and ROI with minus 70-degree large-scale storage suites. Before we begin today's webinar, let's cover some housekeeping items. This presentation is best viewed using the GoToWebinar software for PC or Mac, or by using the GoToWebinar app on your smartphone or tablet. For the duration of the webinar, all attendees will be placed on listen-only mode. If you have technical difficulties, please send a message in the chat window and the moderator will assist you. Throughout the presentation, if you have questions for our presenter, please enter them in the chat window. We will address questions at the conclusion of the discussion during the live Q&A. Without further ado, let's get started. For today's webinar, we will focus on traditional cold storage, including a review of available solutions and their challenges, the advantages of leveraging a large-scale storage suite, and an example of a large-scale storage suite in action. I'm excited to introduce today's speaker, FARRAR project developer Henry Papa. Henry has over 9 years of experience in industrial manufacturing and refrigeration, beginning his career in technical sales and later progressing to supermarket rack refrigeration and EMS/BMS programming. Additionally, he has led development teams in applying artificial intelligence for energy reduction and predictive analytics for the commercial and industrial refrigeration industries. With that, I will turn it over to Henry. The floor is yours.
All right, thank you for that introduction. As Rebecca mentioned, my name is Henry Papa, and today we're going to focus on large-scale storage suites. I cannot say that 5 times fast. My goal today is to walk you through the what, the why, and how we get to these suite solutions. And so we're going to start this off with just a simple poll. You should have got a pop-up, and the question is in regards to what kind of refrigeration you are using currently. We'll give you a couple seconds for that. Looks like we have a pretty good mix so far.
All right, we'll give you about 10 more seconds to enter those poll responses. All right, we're going to close this out, and here are the results.
All right, so it looks like neck and neck, both ULT freezer farms as well as walk-in cold storage. But then we do have some users of large-scale storage suites already, which is awesome. We have some veterans here, and then some other. So let me bring my screen back up. Okay, so as we just discussed and took the poll results, I'm going to guess that almost virtually everyone on here is involved with cold storage in one way or another. So cold storage and refrigeration in general can be seen as a means to an end. But for specific processes and storage of trials, biologics, and vaccines, it is not just an important part of your process, but an integral piece of discovery as well as development. And just the same as if we were selecting new reactors, process lines, we want to consider the best options for specific refrigeration needs. So in our time today, we'll discuss the pros and cons of existing solutions, how we can take the best pieces to create a path to a pretty sweet, ideal solution. Now to begin with the available solutions, we start with the most common, which are reach-in freezers or ULTs. Now from a high-level perspective, Reaching freezers are good for a couple of reasons. One, they're portable, they're plug and play. Each freezer can have its own independent set points for all types of various substances. And on the spectrum of all the solutions that we'll talk about, they're the least expensive. However, ULTs fall short, most importantly, when it comes to performance. So what you see here is a FARRAR ULC, and it was developed with performance in mind. Now, if you're unfamiliar with the FARRAR ULC line, feel free to swing by our website. You can view past webinars. You can reach out to your FARRAR account manager or drop a note in the chat and we'll have someone get back to you. Now, the FARRAR ULC has three key areas of performance where it picks up over your traditional ULTs. And it all starts with the machine sections. It's where the magic starts. Each machine section is a package cascade refrigeration system. They're capable of handling not only 2 to 8 C, but as well as -20 down to -80 C. And unlike ULTs, ULCs utilize forced air convection, meaning you have air constantly circulating throughout the cabinet. So as a parallel, if you think about your home central HVAC system and how much more efficient and effective it is rather than opening a cooler full of ice in the middle of your house and allowing that to cool down your home. Now, because of this forced air technology, ULCs recover faster. Because the air is constantly moving, ULCs have better uniformity, which ultimately will lead to better yield and better efficacy. So what you see here is one unit with redundant machine sections. Unlike ULTs, defrost is automatic. So that means there's no need to move product or put a freezer out of commission for defrost. Now, because of the redundancy, the spare unit can keep the chamber at temperature. So even if one fails, you can swap out a machine section while the spare is maintaining temperature. And overall, this equates to more increased operational uptime. Now, lastly, because of the sizing of the mechanical equipment and the redundancy, there's spare capacity. So that spare capacity gives you the ability to not only store, but also freeze. And you can do that without any additional pieces of equipment. So the basis of the ideal solution that we're working towards begins with performance. And we consider the same principles of the ULCs and want to incorporate that, the advantages of forced air convection, of redundancy, and the spare capacity. So another place where typical reach-ins fall short is storage density. Now, for most of you, I doubt you have single ULTs. You probably have dozens, if not hundreds, or even more. And they're probably set up in an array like shown above, known as a freezer farm. So again, in comparing traditional ULTs to something like the FARRAR ULCs, ULCs excel in storage density. Now, what we see in this picture here is a 2,000 square foot room. On the left, we have 16 ULCs contained, which is over 4,000 cubic feet of storage. For that same equivalent cubic footage, the ULT room would have to be double the size. So what benefits do we get with going to an option like a ULC? It would mean less overall space, less energy consumption, less heat being introduced to our building, and of course, less service costs. But what if we went a step further? What if we were to take that same room, insulate the walls, the floors, the ceiling, and install mechanical equipment to make the whole space refrigerated? For that same equivalent cubic footage of the ULCs, now we could shrink the room down to a fifth of the size. And again, the same benefits. Because we reduce the footprint and the number of pieces of equipment, we reduce energy consumption, we reduce our maintenance spend, and we reduce the amount of heat generated into the space. And you also have to remember, this means less validation. A walk-in would be a single point of validation rather than your hundreds of ULTs. So density is going to pay you back, not only in usable refrigeration space, but also the time required to handle the freezer farm worth of validation. So coming back to our roadmap here, it's step 2, we've incorporated the performance, and now we've incorporated optimal storage density. So we're receiving payback from reduced square footage, less energy consumption, meeting sustainability goals, less maintenance spend, which reduces our operational spending, and less validations, preserving time for quality and compliance. So storage density brings up the other most common solution, which was neck and neck with reach-ins, which is a walk-in freezer. So I personally equate a walk-in to a custom-tailored suit or a dress. You can buy a solution off the shelf, something modular, or if you're feeling fancy, you want something that is dressed up to the nines, that is perfectly fit to you, or your footprint, your workflow, and all the accessories and materials necessary. So this is a truly customizable end-to-end solution. So here's a 3D cutaway of a walk-in freezer. Now, beginning with the main freezer chamber. Here we see the mechanical equipment. So equipment can and should be sized based on SOP, based on specification. So when considering equipment sizing, here are just a couple of questions you could start with. What is the temperature of the product you're storing? How much product are you storing? What temperature or state does the product come into the space? Do you need blast capability? Are you freezing the product as well as storing it? How often is product being brought in as well as out? And do we need redundancy for that safety mechanism? Now, the materials used in construction of a walk-in chamber can be selected to meet large differential temperatures. So the thickness, the insulation, the R value of our thermal panels, the types of doors you're using, whether that be manual, automatic, do you want a viewport, for any type of compliance, like a clean room. And you can also choose these materials to be suited for indoor as well as outdoor applications. Now, as far as material handling, we talked about sizing of equipment, but we also have to consider with all the product we bring in, how are we bringing it in and how are we storing it? So we could choose our material handling to be suited for the packaging as well as the weight of the product based off of our workflow requirements. So if we need the ability for people to walk in and out, to use carts, hand trucks, or even something as large as a forklift, is this a drive-in freezer? And of course, even the controls are customizable. They can be selected for required features, for easy integration to our existing SCADA, EMS, EMS. Do we want remote monitoring? And of course, the need for redundancy. So truly end-to-end walk-ins are customizable and tailored to your standards. So we're almost complete. We are almost to this ideal solution. So far, we have a well-performing chamber that has an optimized footprint, and now we know it can be infinitely customizable. But before we go ahead and install some type of solution, we have to consider what kind of common constraints reach-ins and walk-ins typically run into. So when looking at the space First of all, we want to just understand, is there anything in the way that might limit us? This could be dimensional. Another constraint that has to be weighed is the heat of rejection. Now remember that when heat is removed from a chamber, it needs to go somewhere. Typically with regions, heat is going to be rejected into the surrounding space. And at this point, the building HVAC absorbs that heat and rejects it outside the building, whether it's using air or water as the heat transfer medium. Now, although the surrounding space to this freezer farm shown here is air conditioned, typical air conditioning is around 20 degrees Celsius. So every time you open a region, maybe if it's at minus 70 or minus 80, that temperature delta can exceed 100 degrees. That's a huge heat load every time the door is opened, and it's only exacerbated more every single second that door is opened. So remember this, although you have a available footprint for additional freezers, there may not be enough capacity to remove heat from the space. And if this isn't taken into consideration, this can affect all of the freezers that you have. It could be affected by poor performance due to the compounding heat, which can inevitably lead to early failure and, of course, spoiled product. Now, increasing the building HVAC can be done. However, it's a pretty large undertaking. So to do this in another fashion, we can reduce the load and reject heat by refrigerating the surrounding space. By doing so, the additional equipment can drive a lower temperature delta, leading to faster recovery. That means less wear on your freezer equipment and less worry down the road. So the most common additional refrigeration equipment is inside of an ante room. An ante room is a temperature controlled space leading into the main chamber of your freezer. By temperature controlling your ante room, you reduce the load, meaning less runtime of your freezer equipment, less overall wear, and more efficiency. Now, in addition to temperature control, ante rooms can also control humidity or moisture, which is the other main source of load. Now, this can be controlled in the surrounding space, like an ante room, as well as in the chamber itself. Let's talk about a couple examples. So to recap, one of the biggest pain points of refrigeration in general is moisture. Moisture is introduced into your chamber from people, from products, from infiltration, and from the surrounding space. When moisture freezes, frost accumulates and insulates stored material, which is going to reduce your heat transfer efficiency. Frost and ice also accumulates on your evaporator coils, which may not only reduce capacity, but can also lead to compressor failure. Now, traditionally, frost on coils is removed through defrost cycles. A defrost cycle is heating up your evaporator coil to melt off ice. That water is then drained. Now, usually these cycles take around 30 minutes or so. And although you can mitigate the heat from defrost transferring into your space, it's still going to occur. So the more you can limit moisture, the shorter your defrost duration and the less heat that's introduced into your space. Again, leading to better efficacy, better yields. Now, moisture can be reduced through several means. We talked about HVAC. There could be upgrades to a central rooftop HVAC unit, like a reheat coil. You could use refrigeration to reduce that moisture, or you could use a standalone dehumidifier, something like a desiccant dehumidifier. Or one thing you could also do is to constantly feed dry air into your low temp spaces with a dry air purge. Okay, so we did it. We completed this roadmap. We have a high performance leading to better efficiency. We have optimized space for sustainability, customization allowing for flexibility, and now we know how to meet the constraints to help boost the efficiency. By combining all of these, we get to an ideal solution. So let me introduce you now to the large storage suite. And what is it? A large-scale storage suite, conceptually, we want to have a thermal enclosure. That's going to allow us to optimize our available footprint. By splitting the enclosure into separate chambers, very similar to regions, we have the ability to have independent set points. We have options now for material handling. So depending on what type of product, what type of packaging you have, you can flex that in each of these chambers. Now these spaces, we can size for specific material. And by splitting these chambers, that also means less door openings, again, meaning faster recovery. Now, by utilizing the FARRAR machine sections from the ULCs, we get those benefits. We have the ability to have high performance, flexibility, easy serviceability, which equates to uptime. Now, to improve the efficiency of this suite, we can refrigerate with right size equipment the corridor. And to meet constraints of the building and to help further reduce moisture and heat load to prolong the life of the equipment, we can add in an anteroom, both temperature and humidity controls. Pretty sweet, huh? I had to throw a joke in there. All right, so here we have an external view of one of the common configurations. So this configuration makes service a breeze. Both control panels as well as the machine sections are isolated above the suite. So this means there's no need to shut down a chamber for service. Temperature can still be controlled, again, remembering we have redundant systems. And because we can service from outside of the chamber, there's no unnecessary door openings introducing heat into our temperature controlled spaces, no longer putting product at jeopardy. So it's fast turnaround time with no disruption. With the isolated control panels, it makes it easy to look at operations all from one place and not need to go into the controlled space for something as simple as a set point change. Now, one of the really cool things that we could do here to add true redundancy is to include both air-cooled as well as water-cooled machines. And so with the future in mind, remember the flexibility with the FARRAR suite. You're not married to set points, unlike other solutions. As you have new projects, new product, or reconfigurations, you can flex your set points. Again, 2 to 8 C, -20 all the way down to -80 C. So with this storage suite, we're getting all of the benefits of both reach-ins, walk-ins, and then some. Now, some of the high-level advantages of these storage suites, again, we talked about the magic that happens in our machine sections. They're flexible. They're adaptable to any cold application, 2 to 8, -20, -80, -70, all done with a set point change. We have the ability to be air-cooled as well as water-cooled, or you can do both. With the redundancy, we can maintain temperature through defrost. Because we have these cabinets, there's no concern for safety and logistics challenges accessing -80 C chambers. And we talked about it. There's no operational challenges with defrost because we can have the spare machine keeping temperature. So this storage suite technology really does allow for endless flexibility. Now, I know you're probably wondering, well, what would be the process to incorporate, to build one of these suites? And it really does start with a discussion. So if you have a project in mind, look at your specification. Let's go over it. Let's talk about your needs, both immediate and future state. And sometimes it is an art. Sometimes it requires a site visit or an assessment. I like to equate it to someone renovating an old home. Some people just have that ability to walk in and see a solution. So sometimes it starts there. Now let's put that process in action by discussing a case study here. Now, this is one of the recent projects that really highlights the advantages of the storage suite for one of our pharmaceutical clients. Now, while meeting with a CMO, they had a specific couple of requests. Came through as 2,000 square foot more of 2 to 8C sample storage. Okay. Additionally, they wanted 250 cubic feet of -20 as well as -70 capacity. For us, perfect. We could do a walk-in, we could do a ULC. But as we started to progress and learn more about this renovation, some challenges were identified. So firstly, the only available space in their facility was existing office space. Building HVAC was already maxed out and not able to keep up with any additional load. So that prevented us from being able to reject heat into the building. And because this was already existing office space, there was MEP or mechanical, electrical, and plumbing above the space. So there were height limitations that we had to work under. After more discussions with the client, they let us know a couple of the values, the key benefits that they needed from a solution. Number one, the space density was key. Because this building was already maxed out in space and HVAC, they wanted to optimize the space. They asked us for 100% mechanical redundancy. They really liked the benefit in operational uptime. And because of unforeseen future state, they wanted to have flexible set points. So what we see here on the right is a mock-up of the solution. So looking at this overall, we firstly see the ability to adapt to existing spaces. You probably know this, most walk-ins are either rectangular or square. This, we had to play around with some geometry. Now looking from a top-down view of the suite portion, you'll notice some key similarities to the traditional suite layout that we talked about earlier. The corridor or the room space was kept at 5C, which would give the necessary 2 to 8C storage room. We incorporated high density shelving for additional capacity. Remember how we talked about the maxed out HVAC in this building? So this 5C space not only serves as refrigeration for storage, but it also gives us a mechanism to absorb heat from the cabinets and reject it outside. So we were able to fit 2 low temp chambers inside of this space with our packaged machine sections. Due to the height constraints that we talked about, we were able to engineer and move the machine sections off of the top to the sides of these cabinets. So we still maintain all the benefits of the ULC performance. Now, each of these machine sections did have the 100% mechanical redundancy as asked. And again, that means the extra capacity, the automatic defrost, and more importantly for the future state, flexibility. We have the -70 on the left side, the -20 on the right. If it fits their workflow better, we could flip them around. If they reconfigure this space and these cabinets, we can change the set points. So just as a takeaway, I mean, it's almost been a year since this has occurred. So just one anecdote I'll leave you with, but last year, a janitor heard an annoying alarm from a reach-in freezer, and instead of following the proper protocol, they unplugged it, ruining 20 years of school research valued at over $1 million. So it's just one thing to always consider when thinking about refrigeration. Again, I started off saying refrigeration can be seen as a means to an end, but when you look at implications of something like this, you can see the real impact if it isn't correctly trained, if it isn't correctly engineered. So in summary, to recap these large-scale storage solutions, I want to answer the why. Why go with a suite? So if you have large storage, hundreds, thousands cubic foot, and need flexibility, these suites will give you the performance of industry-leading regions, the storage density of a walk-in, the ability to customize your specifications and meet the constraints of your footprint, really making it the ideal solution for bulk storage.
All right, thank you so much, Henry.
Yeah.
Now we will open it up for our live Q&A. If you haven't already, please go ahead and enter your questions for Henry in the chat window, and we'll start answering those questions now. So Henry, our first question is, what type of refrigerant does a large-scale storage suite typically use?
That is a great question. So right now, in the industry, the most common is going to be R448A for the high side, and for the low side, typically it's 508B. However, we've seen promising refrigerants like propane, like ethane, but due to charge limitations, it's still not viable. But as new refrigerants come out with lower GWPs, we're always taking a look and seeing what can be used in the future.
Great. So another question here, are there any design limitations with a large-scale storage suite, or is it truly 100% customizable? So thinking of materials, material handling, controls, etc.
Yeah, that's another great question. And I guess to recap, really these suites are truly 100% customizable. It really depends, though, on the need, the specification, the space that we have available. But we can always tailor them to meet those needs.
Perfect. And piggybacking off that question, is there a minimum footprint requirement for this type of solution?
Yeah, and really, I think there is a trade-off, and I think the point where we want to start considering a suite is probably going to be over 500 cubic feet. Otherwise, you may want to just look at a reach-in or going to a walk-in. But if you have that much need for storage and have the need for flexible set points, that's when we can start to consider a suite option.
Kind of staying in that same vein of customization and sizing, does FARRAR provide shelving and or material handling for these solutions?
We can, yes, we do.
Great. All right, so we're gonna pivot topics. Are there any energy savings or energy efficiency gains from using a large scale storage suite as opposed to a freezer farm or other type of solution?
Absolutely. Because the less equipment, you have less inrush current. Because of the corridor, the ante room, that's going to make your machine sections much more efficient because they have less TD, and so it's easier to get down to temperature, faster recovery time. So overall, you're going to have less energy spend going to a suite rather than a freezer farm.
We have another question here. What specific applications can large-scale storage suites be used for?
Yeah, and really it's very wide. So it could be pharma, bioprocessing, repositories. So for any CMOs, CDMOs, virtually anytime you need large storage for longer periods of time, and you have the need for flexible set points, these will be a great solution for you.
All right, so we have just a few more minutes here for Q&A. So if you do have any questions for Henry, if you could put them in the chat box now, that would be great. So one last question I have here in the queue. In your experience, what roadblocks are most common in getting this type of suite estimated correctly? Is it confirming customer specifications or something else?
Yes to all of the above. So yeah, for us, for walk-ins in general and these suites, it's making sure the specification is correct. It's making sure we're looking at not only just the immediate needs, but the future needs. How is this going to be used in the future? What changes could occur? How this space can change in the future. I'm just trying to think of some other roadblocks we commonly run into with this. It could be something as simple as geographic location. But yeah, we have a pretty extensive questionnaire to get all of that information up front, so we do have a little bit better ability to estimate these correctly.
All right, so it looks like that's all the questions we have in the queue. If you still have questions, please go ahead and enter them in the chat window, and we can follow up with you after today's presentation. If you would like more information on FARRAR's walk-in engineered solutions, we have several resources in the handout section of GoToWebinar, or you can visit www.farrarscientific.com. When today's webinar ends, you will be directed to a survey. Your feedback is important to us, so please take the time to complete the survey. Let us know how we did and what topics we should cover on a future webinar. That concludes today's event. Thank you, Henry Papa, for leading this insightful discussion, and to everyone for joining us. We hope to see you on the next one. Have a great day.
Thank you all.